Okay, everybody. So I think we got a pretty good handle on what we have to do up here, as far as all the functions that we can use and what we have to make over here. And I'm going to say this in the exam, but also here. You can always ask me questions about this. I mean, always. So if something's feeling confusing, just ask. I'd be more than happy to kind of give you some pointers and some ideas and kind of coach you through it. The last thing I want to talk about is just these numbers down here at the bottom. These other numbers are fairly straightforward. 1,536, 20,736, 3,748,100. Those are all fairly straightforward. Then you get down to the slightly larger ones. This is 4.3 billion. That's a big number, but not an unheard of number. But then you get to these monsters down here. And you got to remember, you can make these using only fours. Only fours. I'm going to give you one more hint. I know for at least one of these two things, I use the number 44, which just puts two fours next to each other, which actually makes 44. Just so you know, you don't have to connect them, all the fours, with signs. You can actually just put them right next to each other. And I know I did that for one of these two, and that's a pretty good hint to give you right there. Anyway, I want to make sure you know what this means. 3.40282E plus 38. So what I'm going to do is I'm going to come over here to your actual exam, and I'm just going to write that number. 3.4, and I don't really remember the other numbers. 3.40282. Come back over here. 0282E plus 38. Okay, so what makes this confusing to a lot of students is y'all didn't grow up in the 80s like I did. And the reason that that's relevant is because back in the day when computers kind of hit the mainstream, they always had what's called a single line display. And that is still the case in a lot of computing technology. One of the reasons I'm having you do this part of your exam, and I'm going to have you in Excel more as we go through 98 and then into 105, is because Excel still uses this, as you can see. Now, what I want to tell you what it actually means. When you see this is scientific notation. The E stands for the word exponent. And what this actually means is this: 3.40283 times 10 to the 38th power. That's what it actually means, but you can see why Excel can't write that. You see, when I made the 38 look like an exponent, it actually leaves that single line display. Okay, so this is what is actually being said when you see E plus 38. All that means is we're taking this number here and we're multiplying it by 10. That's what that kind of implies, to that power, the positive 38th power. We'll deal with negative powers soon enough. Okay, so what does that mean? Okay, well, let's just look at some simpler examples. Okay, suppose it was 3.4 blah 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 times E plus 1. Well, that would mean times 10. 10 to the first power is 10. So all that would do would be to move that decimal place 1 to the right because of what you learned in Math 58. So that would be 34.0283. Okay, we talked about why in Math 58 it moves the decimal 1 place to the right if you multiply by a power of 10. If it were 3.40283E plus 2, you would move 2 places to the right. So that would be 340.283. So every additional power of 10 that you multiply by, you move 1 more place. So what that tells us, this number, or this number, whatever one you want to look at, I'll copy it down here, either one of those two implies that we need to take the decimal point and move it 38 places to the right. Okay, you ready for this? I'm not sure I am. I'm going to do it right now. Okay, I'm going to start with, what the hell just happened? There we go. I don't know what it's doing. Oh, I know what it's doing. There we go. So I'm going to take this off, and we're going to have to keep track of all this stuff. So we're going to move it 38 places to the right. 1, 2, 3, 4, 5. If I put it there, I've taken care of 5 of those numbers. That means I still have to do 33 more. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. Holy mother. Now I'm going to make some sense of this by putting commas in, just because this number is so huge, it's kind of hard to deal with. All right, here we go. Here we go. Okay, I think I got it now. All right, let's make some sense. That many zeros implies the number is thousands. That many implies millions. That many implies billions, trillions, quadrillions, quintillions, sextillions, septillions, octillions. I don't even know what comes next. I don't even know what's after octillion. It's ridiculous. Here's the way I look at it. I group them in 12s. So there's 12. That's trillion. 12 more is a trillion, which is ludicrous. And then 12 more would be trillion. So this number is equal to 340 trillion, which is massive. That's just a massive number. But that's what it means. So when you see this pop up, just realize how big that number is. Trust me, we're going to dwarf this number in Math 105. We're not going to dwarf this one. This number is imperceptibly big, but we're going to get close to it in Math 105. We'll play with it. We're talking like age of the universe size number in that case. But like I said, we'll get to that 105. I just wanted to make sure you know when you see this, what you're actually getting. Okay, and you will see it pretty quickly if you start messing with 4 4s and the correct operations over here. You can make those numbers grow really fast. So, just wanted to share that with you. I hope these 3 videos will help you with these last few points on your take home. And like I said before, ask me questions if you get stuck. All right, see you in class.